So we have a centrifuge speeding up from rest. So we know that delta, or rather the omega initial is going to equal 0 radians per second. And we know that the centrifuge is speeding up to 15,000 RPM. We're going to be multiplying this by 2 pi radians divided by 1 revolution. And then there's 1 minute for every 60 seconds. So we'll have a final angular velocity of 1,570.795 radians per second. We should first, we also know the delta t, the time it takes to reach 15,000 RPM. This is going to be 240 seconds. So we should first try to find the angular acceleration. This is going to be equal to delta omega over delta t, or delta omega final minus omega initial over delta t. We know that this is going to be 0, so we have 1,570.795 divided by 240. And this is going to be equal to 6.545 radians per second squared. We can then use angular kinematics in order to find the final angular displacement. So theta final equals theta initial. We know that this is going to be 0 plus omega initial t. We know that this is going to be 0 because the initial angular velocity is 0 radians per second. And this will be plus 1 over 2 alpha t squared. So this is going to be simply equal to 1 over 2 alpha 6.545 times time squared. So 240 squared. And this will equal 188,495.39 radians. Now, to convert this to revolutions, you simply multiply 188,495.39 times 1 revolution for every 2 pi radians. And this is going to equal approximately 30,000 revolutions. So as the centrifuge is speeding up from rest to 15,000 RPM in 240 seconds, it makes approximately 30,000 revolutions during that time interval. And that's the end of the solution. Thank you for watching.